In the previous video, we saw how to work out the volume of a pretty basic frustrum. And the reason why it was so simple is that we were given all of the dimensions we needed pretty simply. We were told the radius of the base of the big cone, we were told the radius of the base of the small cone, we were told the height of the small cone, and we were told the height of the big cone. But that's a bit unrealistic because we're actually given dimensions here that are to do with the cone, the bit that's been cut away, rather than the frustrum itself. So this gets a bit more complicated and also a bit more realistic when we are required to work out extra information for ourselves. So in this question here, you can see I've got the radius of the base of the big cone, and I've got the height of the big cone, so I can work out the volume of the big cone easily, just like before. When it comes to the small cone, I don't know the radius of the small cone, unfortunately. I know the height, but I don't know the radius. So in order for me to work out the volume of the small cone, I need to work out the radius first. But what we actually have here are similar triangles, because if I was to draw a line down here like this, the perpendicular line across here, then I have a right-angled triangle here. And I also have a right-angled triangle here. And I know for a fact that they are similar because the angles are all the same. So if the angles are all the same, I know that the triangles are similar, and I know that their sides are in proportion. So let me just draw these two right-angled triangles out separately at the bottom here. So I know the small triangle has got a height of 2, and I don't know what its base is. So height of 2, I don't know what the base is. The big triangle has got a height of 8, and the base is 12. Now, I know these triangles, like I said before, are similar, and so now clearly I can see that the scale factor here is 4. 2 times 4 is 8, or just 8 divided by 2 is 4. The big triangle is 4 times bigger than the small triangle. Therefore, if this is 12, this must be 3. So I've managed to work out the radius of the base of this triangle, the radius of the base of the small cone is 3. So this is 3. And now I can go through the same process as before. So I can do 1/3 times pi times 3 squared times 2, which gives 6 pi. And now I can take them away like we did before. So 384 pi take away 6 pi is 378 pi. And that whose units are centimetres cubed. So there we go. So the key thing really is that this triangle here and this triangle here are similar triangles. So if that's 2 and this is 8, then I can see that this is 4 times bigger than that. If that's 12, then this must be 3. Then you can carry on exactly the same way as we did with those simpler examples.